of it were moving apart from each other faster than the speed of light. That time is right now. A lot of people make a big deal out of the fact that during inflation, right after our universe burst into existence, the whole universe was expanding faster than light. Now, while that is true, it kind of implies that the universe doesn't normally do that, and it does. I mean, if you pick 2 points far enough apart in our universe, you can always find ones that are moving apart from each other faster than light. That is simply due to all of the expanding space in between. So, our universe is now and has always been expanding faster than the speed of light. But doesn't this violate Einstein's special theory of relativity that says nothing should be able to move faster than light? Actually, no. Relativity says nothing can move through space faster than light, but that doesn't stop space itself from expanding however it likes. Now, it was Hubble in the late 1920s who made the observations of the night sky, which led us to see that our universe is expanding. The further out in space he looked, the faster the objects were moving away from us. So imagine a point so far out there that the average recession velocity is the speed of light. I mean, if you think about it, it's going to be the same distance in every direction. So that would form a sphere, which we call the Hubble sphere. Everything beyond that sphere is moving away from us faster than the speed of light. So common sense would say we would never be able to see the light from those objects because of how fast they're moving away from us. But in fact, this is not true. We can see those objects. To understand how this could work, picture a galaxy beyond our Hubble sphere. It's receding faster than light. It's in a superluminal region of space from our perspective. So any light that emits in our direction will actually be moving away from us as time goes on. Well, that doesn't sound very promising. But due to the accelerating expansion of space, our Hubble sphere is actually getting bigger. And if it gets bigger faster than that light can get away, then at some point that light is going to travel from a superluminal region of space into a subluminal region of space, and so it can start making progress towards us. So we can detect it, so we can see that distant galaxy, which is of course now even further beyond our Hubble sphere, but we can see its light. We can detect that it's there. This is remarkable. In fact, all of the photons we now receive from the first 5 billion years of the universe, they were all emitted in regions of space that were traveling at the time faster than the speed of light relative to us. The objects that emitted them were, are, and always have been moving away from us faster than the speed of light. But their light has entered our Hubble sphere and had enough time to reach us, and so we can see them. So the observable universe is larger than our Hubble sphere. It's actually limited by what's called the particle horizon. That is based on the amount of time light has had to travel towards us since the beginning of time. That is 13.8 billion years ago, as far as we can tell. Now, because the universe has been expanding and that expansion has been accelerating, things are much further out than 13.8 billion light years away. I mean, the observable universe has a radius of over 46 billion light years. The diameter is about 93 billion light years. That is a huge volume of things that we can see. And 13.8 billion years ago, everything in that volume and everything beyond it that we can't see would have been compressed into a tiny, infinitesimally small point that we call the singularity. Actually, no. I mean, that would be true if the universe is finite, but if the universe is infinite, and it kind of looks like it is, then it was always infinite. So the Big Bang would have happened literally everywhere. But if the universe has always been infinite, then what is it expanding into? Well, it doesn't have to expand into anything. I mean, it can expand into itself. That's the thing about infinity. You never run out of it. This episode of Veritasium was supported by Audible.com, a leading provider of audiobooks with over 150,000 titles in all areas of literature, including fiction, nonfiction, and periodicals. This week, I wanted to recommend the book Hitchhiker's Guide to the Galaxy. It's one of my favorites, and it's a classic of the science genre. You know, people often ask me, why is the number 42 on the Veritasium logo? That's because it's the answer to the ultimate question of life, the universe, and everything. So if you haven't read this book yet, you should definitely check it out. And in fact, you can download it for free by going to audible.com/Veritasium, or you can pick any